Assalamu alaikum, dear student. Welcome to the PowerPoint online video lecture class. This is Muhammad Mahawalam, lecturer in chemistry, EMDS, Rajaguttara Model College. So, at the end of the lecture, you will be able to know about crystallization, the experimental steps of crystallization, fractional crystallization, and experimental steps of fractional crystallization, distillation, experimental setup of simple distillation, fractional distillation, experimental setup of fractional distillation, steam distillation and its experimental setup of steam distillation, solvent extraction and flowchart involved with the process, chromatography and classification, column chromatography and diagrammatic representation of column chromatography, retardation factor, RF, and finally TLC. So these are basically the key point of the chapter that we will be able to know at the end of the class. So these are basically taken from the chapter 2 of chemistry first paper. The name of the chapter is qualitative chemistry. So let's start our class. For the first time, I would like to say something about crystallization. You have already seen in the slide. So what is crystallization? When a hot saturated solution of a solid substance is allowed to cool slowly, then at a lower temperature the solution becomes super saturated. So at the higher temperature or at the highest temperature, the solubility of any salt, we know very well, any salt or any solid substances is comparatively high. At lower temperature the solution become super saturated, we know it very well. Okay, so as at lower temperature the solution becomes super saturated, so there must have excess substances, okay, that comes out as solid crystal from the solution. So after having the solution super saturated, the excess substances must comes out and it will comes out as a solid crystal from the solution. So then the solid crystalline substances gets a definite geometric shape which is called crystalline shape. So the process of forming of crystal from super saturated solution is known as basically crystallization. So what is crystallization? Crystallization is basically the process of formation of crystal. The process of formation of crystal. What is crystallization? This is basically the process of formation of crystal from super saturated solution. From super saturated solution is known as crystallization. The saturated solution obtained after crystallization is called mother liquor. So after the crystallization, that the solution that we will have is basically called mother liquor. Okay, again recrystallization is the process of separating impurities from any impure solution. So what is crystallization? Crystallization is basically the process to separate any solid substances from any solution, okay, by cooling it, by reducing its temperature after producing super saturated solution. Okay, so by this way you will be able to impure the crystal. You can make it free from impurities. Okay, so right now I would like to say something about the experimental steps of crystallization. This slide basically indicates the experimental steps of crystallization. So for the first time you have to take mixture of organic solid and solvent. Okay, mixture of organic solid and solvent, then you have to add here heat. Okay, when you add here heat, then these solid substances, these solid organic substances will dissolve in this solvent. By this way they will produce an organic compound. This compound can contain impurities, okay, in addition with it. So for this reason, in order to separate the impurities from this solution, there must happen filtration reaction. Okay, this is the step that you have already seen, filtration. Okay, after having filtration, solid impurities will be separated from this solution. Okay, by this way you will have solution of pure compound. This is solution of pure compound. Okay, now and the temperature of the solution is comparatively higher. Okay, then you need to take it cooling. You need to take a cooling. After cooling this solution, then it will go to the super saturated state. Okay, super saturated solution will be produced in that case. So after having super saturated solution, some of excess solid substances will be sedimented as a crystalline solid. Crystalline solid, after filtration, the mother liquor solution will be passed through the filter paper, and pure crystalline solid will be in the filter paper, okay, on the filter paper. Now only drying is basically the process. Pure just to make sure the drying of pure compound, and by this way you will have dry pure solid compound. So these are basically the process. The main process of crystallization is basically involved with, for the first time you have to heat the system, and later you have to cool the system. After cooling the system, the solution will reach to the super saturated solution state. Then a solid substance will sedimented as a crystalline solid, okay. It will be precipitated as a crystalline solid, and then you will collect this precipitation. So the formation of this is clear to us that this is basically a separation technique of solid substances from any solution, as well as recrystallization, which is used in also for the make sure any solution any solution free from solid substances, okay. So I hope you understand this process. Now the fractional crystallization. What is fractional crystallization? This is another process which is very important. When the solubility of two substances in any solvent is not so much different from one another, then when the solubility of two substances in any solvent is not so much different from one another, then the two compounds can be separated by fractional crystallization involving a series of repeated crystallization. So by this way, by the process of fractional crystallization, you will be able to separate two solid substances from any solution, okay, where the solubility difference of these two substances must not be more different from each other. The solubility of the two solid substances must be closer to each other, okay. So in that case, if you want to make sure the fractional crystallization, this process is basically involved with a series of repeated crystallizations. You have to make sure the crystallization reaction in that case for number of time, okay. This is basically the experimental steps of fractional crystallization. You have seen in the slide. Basically, for example, for the first time you have to take two solid substances where A is comparatively less soluble. A is comparatively less soluble in this solvent than B, okay. So when you heat the reaction system, when you heat the system, then both A and B will dissolve in this solvent. By this way, there will produce a saturated hot solution. A saturated hot solution of A plus B will be produced here, okay. Then you have to make sure the cooling of this saturated solution. When you cool this saturated system, then A, as solid substances S is comparatively less soluble in the solvent, A will form crystal for the first time, okay. And after forming the crystal of A, it will be sedimented, it will be precipitated at the bottom of the reaction container, okay. Then and the solution in that case will have only B solid substances, okay. Now you just make sure the reaction of process of filtration. After filtration, this system, as A has already formed as a crystal, so it will be it will be separated from by filtration way, and crystal of A will be produced here, okay. Now you have only the solution having the solid substances B. Now you have to separate it. You have to separate the solid substances B. For this reason, for this you have to make sure the process of cooling, okay. Just you cool the solution again, or you can continue the process of vaporization, okay. You can do cooling here or vaporization, okay. Then you will able to crystal again, you will able to have crystal of B, okay. So by this way this is possible to to crystal to separate solid A and B from this reaction, from this system. So fractional crystallization, this is clear to us that is basically the process to separate two solid substances, okay, or more than two solid substances where the solubility of both of them comparatively closer to each other. Okay. Okay, now distillation. What is distillation? Distillation is basically a process of separating the components from a liquid mixture by selective evaporation and condensation. So basically distillation is a process for the separation of liquid from any solution. We have already discussed the process crystallization, where crystallization is involved with the separation of solid substances. At the same time, distillation is basically the process for the separation of only liquid substances, and this process is basically involved with the two process. One is evaporation and another is condensation. So I can say distillation is basically equal to the two process. One is evaporation and another is condensation. Okay, so the process involves with the conversion of liquid into vapor that is subsequently back to the liquid. So distillation is basically the process against this is basically this process basically involves with the conversion of liquid into vapor, at the same time subsequently the vapor come back to the liquid. So for the first time liquid will be converted to vapor, and later vapor will be converted to liquid, and this is process for the separation of only liquid substances from the any solution. And distillation can be classified into three processes. One is simple distillation, another is fractional distillation, and last one is steam distillation. So dear student, now about experimental setup of simple distillation. You have seen in the slide basically the experimental setup of simple distillation. You know very well distillation is basically involved with the separation of liquid from any solution. Okay, so this is basically distillation flask, and this is burner for heating the distillation flask. This distillation flask basically contain the liquid substances that is needed to separate from each other. This is the solution. When you heat up the system, this distillation flask, the liquid substances which is comparatively lower boiling point, it will vaporize for the first time. So the substances that is possible to separate from each other by using this distillation process, there must have enough boiling point difference. Okay, boiling point difference. So the liquid substances which is comparatively lower boiling point, it will vaporize for the first time. Okay, then the vapor of these liquid substances will enter into the condenser through this way, and in the condenser there is a tube way. One is water outlet, another is water inlet. Through water inlet, water will enter into the condenser, and through water outlet, water will out from this condenser. So there is a flow of cold water in this condenser. For this reason, when vapor of the liquid substances passes through the condenser, due to having here a flow of cold water, this vapor of the liquid substances has converted to liquid. Okay, and by this way it will stored basically here in this flask. So this is basically the way to separate the liquid substances that is present in this distillation flask. This is basically the way. Okay, so dear student, now about fractional distillation. A mixture of two or more volatile liquid can be separated by using fractional distillation when their boiling point differ by more than 40 degrees Celsius, and the operation can be carried out with the help of simple distillation apparatus. So in case of fractional distillation, you can separate two liquid where the boiling point difference in between these two liquid must not be more than 40 degrees Celsius. Okay, this is very important point, their boiling point difference must not be more than 40°C from each other. At the same time, the operation can be carried out with the help of simple distillation apparatus. Okay, so this is basically the experimental setup of fractional distillation. You have seen in that case, in case of fractional distillation, you have to use special types of column. You have seen in this which one is called fractionating column with packing. Okay, so this type of column, one special type of column, can be used in case of fractional distillation. This is basically distillation flask where basically present liquid that is needed to be distilled. Okay, and this is burner. When you burn this liquid, having two liquid that is needed to separate it from each other, for the first time the liquid which one has comparatively lower boiling point, it will vaporize for the first time, and by this way it will enter into the condenser. Okay, so there is a two-way, you know, one is water inlet and another is water outlet. So there is also a flow of cold water, and by this way the vapor of this liquid will pass through this condenser by this way, and as there presence of cold water flow, the vapor of this liquid will be turned into or come back to liquid again, and it will store as here. Okay, this is basically the distilled liquid, okay, that you have seen in this way. So this is basically the way. Almost fractional distillation and simple distillation is same, but in that case only if you want to fractional distillation is basically carried out in case of two liquid where the boiling point difference between the two liquid not more than 40°. This is very important point here. Okay, so dear students, now about steam distillation. What is steam distillation? Steam distillation is used for separating and purifying liquids which are immiscible water, volatile in steam, and have high vapor pressure at the boiling temperature of water. So you have to understand clearly, this is very important process and interesting process also. The liquid substances, if any liquid substances, if it is not soluble in water, so the point here you have to notice carefully, the liquid substance must not miscible in water. Okay, it must be immiscible in water. If it is immiscible in water, in that case, by using the steam of water, by using steam, you can separate the liquid. Okay, you can separate the liquid. So this is basically the way. Okay, so steam distillation is basically the process where you where there is the use of steam. By using steam, the liquid substances can be separated from one another. Okay, so this is basically the experimental setup of steam distillation. You have seen this is basically steam generator. This is steam generator, very important apparatus of steam distillation process. This is basically steam generator. From here steam will be go into this container. Okay, where basically the compound that is needed to distill liquid substance is present here. So from this side, from this steam generator, steam will be passed through this distillation flask where they are present the liquid substances that is needed to distilled. Okay, so when you pass the steam here, as the steam has temperature near about the boiling point of the substances that is present here, so it will be vaporized, and the vapor will enter into the condenser through this way. Okay, so this is the condenser. There is a two-way. One is water inlet, another is water outlet. So there is a flow of cold water through this condenser, and liquid vapor will pass through this way. When it passes through this way, so due to the presence of cold flow of water, this liquid vapor will be converted to or come back to the liquid substances. So this is the distilled water in addition with water. So basically, as their presence here vapor of the substances, in that case the steam, the temperature of the steam and the boiling point of the liquid that is present in this container must be same. Okay, so for this reason, after condensing the vapor, their presence distilled liquid and water also, both of them will be present here. Okay, both of them will be present here. So this is basically the way. The process name is steam distillation. By using steam, by applying steam, any liquid substances from any container, from any solution, is possible to separate it from each other. Okay, so dear student, now about solvent extraction. Solvent extraction is basically the process by which a particular component from a mixture of solution is extracted with a suitable solvent. So by using a suitable solvent, this is basically the process to separate a particular component. Okay, so the separation of a particular component by using solvent, okay, suitable solvent, is basically called solvent extraction. Okay, we know very well polar compound are soluble in polar solvent. At the same time, non-polar compound are soluble in non-polar solvent. Okay, at the same time, organic compound is soluble in organic solvent. For this reason, an organic compound present in aqueous solvent is dissolved in organic solvent. Okay, which is immiscible in water. An organic compound must not dissolve in aqueous solvent. Okay, we know very well organic compound are basically non-polar. As it is non-polar, so it should dissolve in another organic solvent. It should not dissolve in any aqueous solvent. Okay, so now the condition that must satisfy any solvent which if it wants to use in solvent extraction. Okay, so what are the condition? For the first time, the solvent should be immiscible with water. The solvent, this is the first condition, the solvent that can be used in solvent extraction, it should not be miscible with another solvent, very important solvent, aqueous solvent. Okay, which one is called water. So the solvent should not be miscible with water. This is the first condition. Second condition is the compound initially present in aqueous solution. So the compound that is present in aqueous solution or water solution should be highly soluble in that solvent. Okay, so the compound or component that is present in aqueous solution in water, it must be highly soluble in that solvent. Okay, if you want to separate this component by using this solvent. Okay, so these are basically the condition that must satisfy by the solvent. So dear student, now the solvent extraction process that is described below in the flow diagram. Okay, just you consider this flow diagram to describe the process of solvent extraction. Here there is a aqueous solution that basically contain inorganic compound. You know, inorganic compound are polar, and aqueous solution is also aqueous solvent. I mean to say water is polar, so inorganic compound highly dissolved in this solvent. There is another component, which one is organic compound. It will be slightly dissolved in this aqueous solvent water if it is slightly polar. Okay, so to dissolve this organic compound, there let us consider there we have used another organic solvent. So as this is organic component, so it will dissolve in this organic solvent. So in separatory funnel, so if you shake oil and then the organic compound will dissolve in this organic solvent, and inorganic compound will dissolve in this aqueous solvent. So there will produce two layer, or one is organic layer, another is aqueous layer. Aqueous layer basically contain inorganic compound that is dissolved in this aqueous solvent. At the same time, organic compound, if it is slightly polar, okay, if any polar organic compound is present, it will also dissolve in this organic aqueous layer, and completely organic component will be dissolved in this organic solvent. And so by this way there will produce two layer, one is organic layer and another is aqueous layer. Aqueous layer basically contain inorganic compound with aqueous solvent, and organic layer basically contain organic component with organic solvent. Okay, so from here from here you should collect the organic layer from this, and by this way you just make sure here drying. Okay, when you dry this organic layer, then after drying you just continue the process of distillation. So by this by the process of distillation, organic compound will be separated, and after distillation there will produce organic solvent, and organic solvent will be come back to the separatory funnel again, okay, by this way. And from this aqueous layer it will be directly come to this tank, and aqueous layer basically contain inorganic compound and the polar organic compound. If there present any polar organic compound, so there it will be present, okay. So from organic solvent it will supply to the separatory funnel, at the same time aqueous layer it will also supply to this separatory funnel. So by this reaction will be continue for a number of time, and by this way you will be able to extract any organic component or any component by using this solvent, okay. So by using organic solvent this is possible here to collect the organic component. So this is basically the way, so this is basically the way to separate any component, okay. So dear student, now about chromatography. Chromatography is very important separation technique, you know. So chromatography can be defined as the technique of separating the constituent of mixture by the differential movement of individual component through the stationary phase and phase under the influence of a mobile phase, okay. This is basically the process that basically involves with the two process, namely stationary phase and mobile phase. So this is a very important process, very important separation process, and this process is basically involved with the stationary phase and mobile phase, okay. So what is chromatography? We have already understood the definition of chromatography. Now I would like to say something about the classification of this chromatography. Adsorption and solubility, both are physical properties, okay. We know on the basis of physical properties of substances and principle of separation system, chromatography is divided into four types. One is adsorption chromatography, and second one is partition chromatography, and third one is ion exchange chromatography, and fourth one is permeation chromatography. Adsorption chromatography is basically classified into two steps. One is column chromatography and another is thin layer chromatography. At the same time, partition chromatography is also divided into two steps. One is paper chromatography, another is gas chromatography. Ion exchange chromatography is also divided into two steps. One is cation exchange and another is anion exchange chromatography. And permeation chromatography is also defined as gel permeation chromatography. So on the basis of nature of mobile phase and chromatography divided into two phases, two parts. We know very well there are two parts in each and every chromatographic technique. One is stationary phase, another is mobile phase. So this is basically very important process for the separation of different types of component from different solution or different mixture. So dear student, this is basically the uses of chromatography. Chromatography can be used widely, okay. Nowadays chromatography has manifold uses. Some of them are mentioned below. Separation and purification of organic, inorganic and biological samples. If you want to separate any organic, inorganic and biological sample, you have to make sure the chromatographic technique, okay, you have to use this technique. Secondly, identification of unknown compound with authentic compound, okay. If there is a unknown compound with any authentic or known compound, if you want to identify this unknown compound, you have to apply chromatographic technique, okay. Now the third point, determination of the presence and or absence of particular compound in sample, okay. So if you want to determine the presence or absence of any particular compound, either any kinds of any particular compound is presence or absence in any sample, if you want to determine this, you have to use this chromatographic technique. Now the fourth point, monitoring or follow up the progress of chemical reaction. If you want to monitor or the progress of any chemical reaction, you have to use also chromatographic technique. Determination of the potency and assay value of industrial chemicals, quantitative estimation of a sample, identification of chemical hazards and environmental sample, okay. So determination of the ratio of isomers and components in a reaction mixture. So these are basically the uses of chromatography. So this is clear to us that chromatographic technique has a number of uses in our for different purposes in a different laboratory or commercially, industrially. Okay, now column chromatography. So this is very important technique of chromatography. So the column is a glass tube. Basically column is nothing but this is a glass tube or bullet type tube. Okay, it must be packed with an adsorbent material. So column must be packed with adsorbent material. So which type of material can be used as adsorbent material that can be packed in the column? Basically it can be alumina or silica gel type substances. Okay, it can be packed in the column, in a column. These are basically the ingredients or element of stationary phase. So the packed adsorbent material in case of column chromatography can act as stationary phase. Okay, this solid adsorbent is made into slurry with selective solvent poured into the column and allowed to settle. Okay, then the solution of mixture that is needed to be analyzed is kept on the top of the column so that component can be adsorbed on the column. Now the second solvent, which one is called eluent, is passed through the column. This eluent is basically called mobile phase, the solvent. Okay, this one is called mobile phase, which one will pass through the column. The eluent carries the solute. Okay, non-polar component elutes first, followed by the polar ones. The eluents are collected in a flask and evaporation of the solvent gives separated solute. So by this way you will able to find out the solute or your sample. So this is adsorption chromatography. This type of column chromatography is basically an example of adsorption chromatography. It is basically based on the differential adsorption of the constituents of a mixture and is the simplest chromatographic method. So column chromatography, this is clear to us that this is basically a process which one is involved with the two phase. One is mobile phase, another is stationary phase. Mobile phase is called eluent, you have already understood, and as a stationary phase they are basically used a alumina or silica type substances, which one is called adsorbent material and packed in the column. And the main concept is column chromatography is basically a types of adsorption chromatography. This is very important slide, dear student. This slide basically indicates a diagrammatic representation of column chromatography. Okay, just you look at three column here. Basically this is a column. We know very well column chromatography involves with the two phase. One is stationary phase and another is mobile phase, which one is called eluent or solvent. Okay, so in this column they are basically taken eluent or solvent, which one used here as a mobile phase. At the same time there are also present mixture of component or compound that needed to be analyzed. A, B, C, mixture of A, B, C is also present here, and as it is a column and their presence as a stationary phase, basically a solid adsorbent, which one can be formed by alumina or silica gel type substances, which one is packed on the wall of the column. Okay, when you pass this solvent as eluent from the top of the column, what will happen? Let's say there will produce basically three separated band A, B, C. A, the position of A will be on the top of the column, and B position will be on the middle position, and C on the lower position. Why? Basically we know very well as stationary phase we have used here polar adsorbent. Okay, so A is highly polar. As A is highly polar, so there must have greater interaction with the solid adsorbent stationary phase, and that's why the position of A on the top position, B moderate middle position, as it has moderately this is the, as B is basically moderately polar compound, you have seen moderately polar compound, and that's why comparatively it will have interaction with the solid adsorbent lower than A but greater than C. C is completely a non-polar component, that's why the position of C is on the lower position, and it is very easy to collect the C separate C, as it is non-polar. It doesn't have basically not more interaction with the stationary phase. So A has higher interaction with the stationary phase, that's why the position of A is on the top, highly polar compound, you have already seen in the slide, and B is moderately polar compound. So by this way, A, B, C, three based on the polarity of the three sample A, B, C, they will produce three separated band, and you can collect each of the band after time being. Okay, so by this way you will be able to separate it A, B, C by using this excellent chromatographic technique, column chromatographic technique. So dear student, now I would like to say something about retardation factor, which one is very important factor involved with the chromatographic technique. So this retardation factor is denoted by RF. RF is basically nothing but a ratio of distance moved by the solute and distance moved by the solvent. Distance x by distance y. X is basically the distance moved by the solute, and y is basically the distance moved by the solvent. We know very well when during the time of column chromatographic technique, we have already seen when solvent as eluent pass through the column, there is also happen the movement of the solute. Okay, so the movement of solute, the distance moved by the solute and distance moved by the solvent, this ratio is basically called RF factor. Okay, the greater, if the value of RF near about to the value of 1. Okay, if the value of RF is closer to the 1, then in that case you have to remember the point, the solute can be non-polar. If the value of RF comparatively very smaller than 1, in that case there is a chance to have the solute polar. Okay, if it is polar, then the value of RF will be very smaller than 1. If it is non-polar, in that case the value of RF almost will be nearer to the value of 1. Okay, so there, this is basically a representation for the determination of retardation factor. You have seen this is a slide. This is very important figure. You have seen this is starting point and this is solvent front. Okay, so this is y. You have seen from this is the starting point, and this is basically the distance that is moved by the solvent, and this is the distance that is moved by basically the solute. Okay, so from this experiment we are able to find out the value of RF. So in that case, distance moved by the solute and by distance moved by the solvent, so x and y, x by y is basically the RF or retardation factor for this experiment. Okay, so this is basically the calculation of RF. So dear student, my lecture has been already completed here, and be safe and be well in this pandemic time, and thanks to all.